Last we have is skewness and kurtosis. Okay, so skewness refer to asymmetry in symmetrical bell curve in data set. Okay, so a symmetrical distribution look like this, or you can say a normal distribution where mean and median will be both same. So if the curve is shifted towards left, okay, like this, shifted toward left or to the right like this, it is said to be a skewed data. Okay, so there is three type of the three different type of skewness that we have. One is positively skewed, okay, one is negatively skewed, that is this one, positively is this one, and then last one is symmetric distribution, that is the third one, where mean and median equal to same, and this is what we want every time. So these tapering also known as tails. Okay, so negative skew refer to a long tail on the left side of the distribution, while the positive skew refer to a longer tail on the right side. So basically now you will ask me how to infer these type of distributions. So the mean of positively skewed data set will be greater than the median, but in the case of negatively skewed data, the mean will be less than median. So point 1. Point 2 is the mode of positively skewed data will be less than the median and mean. Okay, whereas for negatively skewed data, the mode will be greater than median and mean. And to infer using value, so if skewness is greater than 1, that I have also wrote here. So if the skewness is greater than 1, or you can say less than 1, there is some skewness and we don't want that particular data because they are skewed data. What we want is, we want data in a way that is normally distributed, where you can say the zero value indicates a symmetrical distribution, where this one is symmetrical distribution, and that is what we want. We don't want the skewness value should be less than 1.0 or greater than uh, I mean less than negative 1.0 or greater than 1.0. We want value in between them. Okay, now what is kurtosis? So kurtosis is like skewness only, but kurtosis is a statistical measure that is used to describe distributions. So kurtosis is defined as a measure of pickedness, and it is generally measure the relative to normal distribution. So there are three categories of kurtosis that can we basically use in our day-to-day life, that is you can see highlighted in the yellow. So first one is uh, mesokurtis, that is this one, which is also called as a form of normal distribution. So this distribution has kurtises similar to normal distribution. Secondly, leptokurtic distribution. So any distribution that is leptokurtic displays the greater kurtosis than the normal distribution, that is mesokurtic. Okay, so third one is platykurtic. So basically this distribution displays less kurtosis than mesokurtic distribution, which means the flatter one. Okay, so similarly a distribution with kurtosis approximately equal to 3 or excess of kurtosis equal to 0 is mesokurtic. A value of kurtosis less than 3 indicates a platykurtic distribution, and a value greater than 3 indicate leptokurtic distribution.